Hello, testing. There we go. So thank you for coming. Welcome to Crash Burn Report. It's a brand new talk that I'm doing for the first time here at NDC Security. And I just want to give a little bit of background about who I am and one of the things that I'm working on at the minute, and you'll understand why, because it provides context for something that I'm going to talk about during my talk. So I'm Scott. You may follow me on Twitter. I write a lot on my blog. But one of the things that are kind of relevant to what I'm speaking about today is a project that I work on called Report URI. Now, at Report URI, we are a security reporting service, if you will. We take security reports and events and information from various different sources, and we kind of pull that all in, aggregate it, filter it, do things with it, and give people dashboards and graphs and the kinds of things that we like. And I explain this because it's very relevant to what I'm going to be talking about throughout the talk. So we're essentially an endpoint where you can send data for it to be aggregated and produced into useful reports. So bear that in mind, and you'll understand the context and the relevance of that as we go through. But I want to start with a question. So before we get going, I want us to all try and understand, what is a browser? And this is an open question to the floor. What is a browser? What do they do? What is the purpose of a browser? Anyone, someone, help me out, come on. This is an interactive talk. Go on, Steve.
Serve content.
To serve content. Okay, so it's like a viewing device. We have all of these different web browsers, and could we all agree that they are there to allow us to view things online? They're like a portal into something that we look at. And this is like the very traditional view of a web browser. You sit down in front of one, and you might go to a website and read some content. You might go to an e-commerce website and purchase something. But the browser is still just this portal to the thing that you want to look at. You can potentially do some interactions on this side and send your order and your credit card details back. So they're typically viewed as this like very kind of, at least for me, like one-sided thing. So depending on what your website is, mine is a blog. I really want people to come to my blog and read it. That's why I built my blog. That's why I write blog posts. You may run an e-commerce website, and in that situation for you, like the functionality and operation of your website is even more important because it's literally how you make money. So everyone has like varying levels of how important it is that their website is available and is online and working in the correct and expected fashion. And we have lots of different tools that I'm sure many of us here use to help us do this. So we think about like the traditional browser scenario. The browser is going to come along, it's going to issue a request. You want to go to a website. Now, we have lots of different tooling to monitor just this single action. Someone's come to our website and made a request. We've got things like application logs, we've got server logs, we've got error tracking services. I used to use New Relic, recently started using Papertrail, but we collect all this information. What is happening? Are things working? Is everything okay? And our server will generate a response to the request, and it will send that back over to the client. So it's like, okay, you asked for this page, here is this page back. But we can even sometimes send things back with the page as well. Maybe we have some kind of client-side error monitoring. Now, some of you might know Track.js, Todd Gardner, who's a big NDC speaker in Rub's PubConf. He runs one of these services. So we have like this whole loop where we want to make sure everything is going okay throughout this entire process, and we have these additional things to add to that. Now, all of these kind of work on the assumption that the request and the response work, right? Like you make the request and then we can log the fact that the request happened on the server side. So we've got our application server logs. We send the response back and then we can log stuff that happens on the client side as well. But this is all built on the assumption that the browser could actually make the request. What if the browser can't connect? What if something like this happens? So I have a subdomain on my website that does not have a DNS entry, obviously for simulation purposes, but you try to go to this subdomain and it will say error NX domain. It means there is no IP address for this domain. Will I have an entry in my server logs to show that? No. Will I have any application logs? Will I have any of my client-side libraries telling me that this thing has happened? How do you know that this thing has happened? And this is kind of the problem, right? Because there's many, many different scenarios where the user can end up with something similar to this, where they try to go to your website but just didn't get there. So we take this scenario. Well, if the client can't connect because there's no IP, or any one of a whole other range of issues we're going to talk about, then that request didn't actually happen because we couldn't resolve the IP. If that request didn't happen, then none of these things can help us. And if there was no request, then there was no response. which means none of these things over here are any use either. So now we just have a client sat looking at a screen and we don't know anything about them. And this is kind of a problem, right? Because this is a really big potential scenario for failure that we don't know about. So the purpose of this talk is to talk about a new feature that's currently built into Chrome and will hopefully soon be built into the rest of the mainstream browsers. Something called the Reporting API. The Reporting API is, in very simple terms, the ability for the browser to send out-of-band reports about failures that happened when it goes to your website. So we're going to take a look at quite a few different things, but just to visualize exactly what that looks like, go back to our scenario here. Browsers made the request, something went wrong, DNS failed, didn't get the response. But what you can do is with the reporting APIs, you can give the browser an out-of-band reporting mechanism to send a report. So this is one of the few things that we collect to report UI. And to be clear, this can be any external service, right? Like you can stand up your own reporting endpoint to ingest this data. So this is an out-of-band report. It doesn't matter if this connection to the host completely fails and breaks down, DNS is toast, whatever it is, you can still have the browser alert you via the reporting API. And there's lots of different things that it can alert you about. So first of all, on your site, you've actually got to tell the browser that you want it to do this. You have to enable the reporting API on your site. And it's this simple. The report to header is just a HTTP response header, like all of the other headers that you can see here. So depending on how you set headers in your application, this could be a line of server config, a line of code, this could be a little toggle box on your CDN provider. It doesn't matter how you put the header there as long as you put it there. And inside the header you can see there's some JSON. I'm going to expand that out so we can look at it. This is what you put inside the report to header, and this is how you instruct the browser that you wish it to send these reports. So we say, right, the group has to have a name. I've just called it default here. We'll see that reference throughout the rest of the talk. Max age. This is really important, and this is kind of where the magic comes from. So you imagine if the browser goes to your website, this is set via a HTTP response header. But if the connection fails, we can't get a response header, right? Like this is kind of the problem. We've got a chicken and egg situation. So once you set this, the browser will remember it. And it will remember it for the duration of max age, which is a number of seconds. So what I'm saying is the first time the browser comes to my website, the connection works. I'm saying from now on, if you come to my website and there's an error, I want you to send a report. So the next time when the connection fails, it doesn't matter that the browser can't get this header. It will remember it from last time. And this is how the reporting works in scenarios where there is no connection at all. Endpoints, you can define where you want the browser to send the report. So again, this can be any endpoint that you like. I'm just using my demo account on Report UI, which we're going to look at later. So you say this is where to send it. You can actually define multiple endpoints if you want as well. So the browser will fall back through those. If one of the endpoints is busy, unavailable, you can have some backups. And include subdomains kind of does exactly what you would expect. If I put this on scotthelme.com, I also want reports for all of my subdomains as well. And this is all that you have to do to enable the reporting API. All this does is specify where the reports go. What you then have to do is kind of like subscribe to different reports, if you will. You have to then say to the browser, okay, in which scenarios I would like a report to come? What kind of things do I want you to tell me about? And there is a whole boatload of different reports that you can subscribe to. My favorite one, and the one we're going to spend kind of a good bit of time looking at, is something called network error logging. We sometimes refer to this as NEL. Now, network error logging has a very particular purpose, and it covers the scenario that I just gave in my demonstration, where basically, for some reason, the browser can't get to your website. And there's a whole raft of different issues that we can look at. So these are the current error codes that are supported by NEL that you can get reports about. So if we think, this is the example from the beginning, right at the very basic start of a connection, someone types in your domain, the browser has to do a DNS lookup. Your DNS server is not available. It does a lookup and the domain doesn't exist. There's no IP. Maybe the DNS lookup fails for some reason. So you can know straight away about all of these issues that would be preventing your application from loading that you otherwise wouldn't really see. Now, you could have like a DNS monitoring service. There's a couple out there who have servers all around the world and they constantly resolve your DNS looking for errors. But the ultimate source of truth really for is your DNS working is the browser. If the browser can't resolve DNS, I don't care what anyone else says, DNS doesn't work. But this isn't all that NEL covers. Going from DNS, we then go to the next phase of the connection, which is, okay, we've got an IP, now we need to make a TCP connection to it. Okay, what can go wrong with TCP connections? Well, it turns out all of these different things. Maybe it times out, it was reset, it was refused, it was aborted, the address was unreachable, or it failed for some other reason, but it's failing. So again, when the browser connects and you still can't get to the page, you can know about all of these TCP errors. The next set of errors are probably my favorite ones. So I did a 2-day workshop just previously here at NDC on TLS. So we do a really advanced 2-day workshop, hands-on, and we build a server with full HTTPS. And it turns out that there's lots of things that you can do with HTTPS to break it and screw it up. So if the connection fails at TLS, maybe you've got a version mismatch. You're not supporting the correct protocols, correct cipher suites. My particular favorite one here is this one, cert invalid. So maybe it was invalid because you served the wrong one. Maybe it's expired and you forgot to renew it. This is something that we see a lot at the minute. But there's lots of different things that you can screw up here. And it's quite easy sometimes to do this. So again, if the user comes to your website and they have this big, great error message on the screen, do you want to know about that? Because some of these could also be security related, especially the TLS ones. Last one to look at is HTTP. So finally, you manage to make it all the way up to the application layer and you make your HTTP request. Something can still go wrong. So we've got, again, the one here. Who's seen these recently? Like redirect loops. If I'm using OAuth signing for different websites, especially on Google at the minute, I don't know why, but I seem to just end up in these redirect loops where I have to flush all my cookies to get the website to work again. And these really annoying application things, again, you get the big error message that just says there's a redirect loop, you can't go to this website. Wouldn't you like to know about that if you were the application host? So one of the ones that I want to pick up on in particular, because we've started to see this an awful lot more recently, is around certificates. This is a pet peeve of mine because, yes, I do a 2-day training course on TLS, but as we're moving forwards right now on the web, we're going towards a more and more encrypted world. And what I'm actually seeing is, rather than people getting better and better at managing certificates, it kind of seems to have gone the other way a little bit, in that we see more and more people breaking their websites because they do things like forget to renew the certificate. Now, to be clear, you should never get to this point, okay? Hopefully you should have some process in place to prevent this being the final solution. But sometimes this is where we end up. So if you want to know about this, you have to enable network error logging on your site. And again, this is super easy. In the report to header, we specify the endpoint. This is where reports will go. And then you say, okay, I would like these network error logging reports. And to prove the point of how easy this is, I shrank the box right down. This is all you have to issue as a header in your application. You go into the application and say, right, this is the NEL header, report to default, which is the group that we specified earlier, and then how long would you like the browser to remember this particular policy for? And you will now get all of the report types that we just talked about. Anytime someone comes to your website and your DNS is broken, you can't make a TCP connection, your cert's expired, your users are stuck in an infinite redirect loop, whatever it is, the browser will now dispatch a report to that endpoint to say, hey, I came to your website and this thing went wrong. Here is all the information. And this is what it looks like. It's just a really simple JSON payload. So all you have to do is ingest this on the other side, process it into an elk stack, big table, heck, just send an email if you want. It doesn't really matter. Use our service, but you just take this data and say, right, this browser came to my site and there was a network error on this page here. Contains some other information. I've chopped a bit off the bottom, but ultimately the thing that you really want to look at is the type of error. Now for me, this would be really embarrassing if I got one of these. Cert date invalid. It means that your certificate is expired and you forgot to renew it. But if you're sat and you have a monitoring system like this, the first time a user goes to your website and hits that error message, the browser will fire off the report and say, hey, I just came to your website and there seems to be a pretty big problem. You could be on the receiving end of this report and say, wow. Now, okay, if you've got a really small infrastructure, this might not be so bad, but if you've got a big sprawling distributed infrastructure, this is great because you're taking all of the browsers, all of your visitors' browsers, and you're turning them into a monitoring station. And you're saying to them, look, when you come to my website, everything should work, obviously, but everything should work. But if it doesn't and something has broken, please tell me. And all you have to do is ask the browser. And I don't want to say certificate management is easy. It is getting easier, but we do still see, particularly around certificates, really big examples of people managing to get this stuff wrong. Now, I don't know how Microsoft had a certificate expire when Troy works there, but they did, right? Like, they had a pretty big outage because of an expired certificate. Now, you would hope that Microsoft would have like some monitoring in place to prevent this, or some automated renewal, or maybe even have, something like network error logging, or some external service monitoring them. But ultimately, obviously, something went wrong somewhere, the certificate expired and caused a major outage. Now, they probably noticed this themselves really quickly and got on top of this themselves really quickly. But outside of having a monitoring service or having something like network error logging, there's one more alerting service out there that will usually tell you that something like that has happened on your website. Does anyone know what service that is? It's Twitter. Of course it is, right? This is the last error monitoring service that you want to depend on, okay? Someone coming to you and taking a big old screenshot of your website and saying, hey, you forgot to do this security thing because your certificate's expired. This was kind of funny, actually, because it happened whilst I was delivering one of my workshops last year. And someone in the workshop was like, hey, I just went to LinkedIn and their certificate's expired. So I put it up on the big screen. I'm like, oh, this is awkward. 2-day course on how to do TLS and certificate renewal. And here we are with certificate date invalid. And this was LinkedIn's global country level subdomains. So like uk.linkedin.com, AU, US, DE, NO, all of them. They'd all expired. So obviously something had broken. Now, again, you really don't want this tweet to be the thing that tells you want to know before this. And it even happens to banks. I particularly like this one because it's like homeinsurance.barclays.co.uk. Certificate has expired. Hi, Tom. Could you please try using a different browser and let us know how you get on? Well, unless this other browser takes me back in time, then it's not going to help me. So I guess the point really is that you can know about these things ahead of time. The first browser that touches your page with an error, the browser will call back and tell you. Don't depend on Twitter. So one of the things that I want to take a quick look at, and I'm going to do a live demo. I don't know why. I'm going to try and do a live demo. So I run a project called crawler.ninja. And what I do, and you may have heard Troy mention this morning if you're in his talk, is I go out every single day, I have a fleet of crawlers, and I crawl the top 1 million websites in the world. And I analyze loads of different things about their security headers, like when their certificates expire, as you can probably see here. And it's becoming a bit of a, kind of like a, not really a problem, but it seems to be growing rather than shrinking. The fact that people have certificates that expire. So I'm going to jump over to crawler.ninja. If you want to go to the project, all of the data is open. One of the things that I'm going to look at just now is the high-level statistics. So you can see here, this file was created yesterday, about 1947. So the crawler does this every day, and then it dumps all of the data into these folders so you can go and look at them. So some of the things in here can be like up to 24 hours out of date. There's 3 interesting files that we're going to look at. So we've got certificates expired, certificates that expire in 1 day, 3 days, and 7 days. If you're running a website, you really shouldn't be in any of these lists. You shouldn't, 7 days maybe. Okay, so let's take a look at 7 days. I could kind of understand if you've got 1 week left on your certificate, you might be just about to start the process. So, I also don't know what domains we're going to see in here, so like, fair warning given, this could get interesting, but let's find, I'm going to regret that, aren't I? So let's find someone in here who's a big website. 54,000. So the number on the left is the rank. So that's their rank in the Alexa top 1 million. So this is like the 54,000th largest website in the world. Let's see if they've changed their certificate in the last 7 days. So it expires on the 31st of Jan 19. So yeah, they've got pretty much to start get moving on their renewal. Okay, so 7 days, that's absolutely fine. Let's go find a different one. Let's go back. Let's have a look in 3 days. 3 days is pretty much enough time for most people to get moving and renew their certificate, right? So let's see how many. I'll tell you what, let's just search for .no. Ooh, does anyone know what this website? Does anyone work here? No, good. Okay. So I was about to go to a different website if the answer was yes to that question. So let's have a look at Bohemia. By the way, if the website I'm about to open is not appropriate, then please yell before I click the button, okay? No one's going to tell me. So this one expires on the 25th of January 19, which is literally today. Oh gosh, so let's actually, tell you what, let's drill down into the time. So this is valid too. Ooh, so that's like right after my talk. Okay, but this is kind of the point, right? Like, so what we'll all do now is we'll find this organization's Twitter handle, we'll wait until like 1 minute past 1 this afternoon, and then we'll all tweet them and be like, hey, your talk went down, and it was because Scott told us so about an hour ago in his talk. So this is problematic, right? And I know that Nell won't catch these things before they happen, but this is about to happen to this organization, and then they'll have no clue that it's happened until we all tweet them after the break. So I feel really bad that they're about to go down, and they may do so, but let's have a look at who's expiring even sooner. Okay, so there's no Norwegian ones in 1 day. Let's go to the last one. Are there any .no domains in the expired certificates list? Let's have a look. Oh, there is. There's one. So who are these people? I wonder if they've renewed, because they could have renewed in the last 24 hours. So let's just check this out. Nope, they haven't. Error cert. Okay, so this is exactly the point, right? Error cert date invalid. When did they go down? Oh, 16th of Jan. They obviously don't care about their website. So if I had gone to this website and they had Nell enabled completely transparently and without my input, the browser would have dispatched that report in the background. They would now have that JSON payload in their possession to say, this browser has just come to your website and the certificate is invalid because it's expired. And this is exactly the point of Nell. It's not meant to prevent the problem, it's your last line of defense, that when something does go wrong, you can know about it reliably and immediately. So, that demo went quite well. I'm really happy with that. You can go and have a look on crawler.ninja. There's loads of other stuff that I put in there. Alongside certificates, we do like protocols, security headers, cipher suites, things like that. So do go and have a look at that. It's completely open. All the data is free. If you like playing with big data, I think I've got about 900 gig worth of crawl data now. So you can go have a fiddle around with that. So that was just Nell. That was just the first feature that can use the reporting API to send these reports. So the reporting API is just the thing that sends the stuff. There's then all the different types of reports that you can subscribe to. So network error logging is probably my favorite because it covers this huge unknown space. The person that never gets to your site. Right now, there's no other way to collect reports about those. So that's why I particularly like that one. But network error logging covered. Next up, deprecation reports. I actually really like this one as well. In the UK, we have a supermarket called Sainsbury's, and like most other retail stores, retail outlets, you can go to their website and there's some kind of store locator. If you click on this little kind of like crosshair button up here, it will ask your device for its location, so it can drop a pin on the map, and then it will plan a route to your nearest store. I assume you have similar concepts here in Norway. Why will this page not work? Okay, so I have location services enabled in my browser. I'm giving them a fair chance. I've not intentionally disabled location services. Bingo. It's not a HTTPS page. Truthfully, who here noticed that? Okay, that's pretty good. A room full of security people noticed that we're not on a secure connection. The problem here is that this page is going to try and use the geolocation API built into the browser. So with the geolocation API, with like browsers, especially on mobile devices, you can get a fairly accurate location from them. So you click the button, it pops a prompt and says, hey, this website wants to know your GPS coordinates. And you click OK, and then it says, go down this road to the store. Chromium and then all of the other browser vendors realize that if I send my GPS coordinates to this website, I'm sending them over HTTP. Would you consider your GPS coordinates to be kind of personal / sensitive data? I mean, they pretty much uniquely identify you because we can like go drop a pin on your head on the map. So all of the browser vendors said, okay, look, this is a powerful API because it accesses sensitive information. We're going to deprecate it on HTTP. Now, of course, there was an entry on like the Google developer blog. How many people do you think read that? And I know the answer is probably quite a lot, but like in the grand scheme of the world and all web developers ever, how many people do you think read that deprecation blog post? And the answer is like basically none. So the deprecation day came in the UK. I was watching a few of these websites that had these services, and on the day of the Chromium update, you do the Chrome update and you press the button and it's like, dead. Nothing happens. And then you're like, hey, Sainsbury's, your store locator doesn't work because you're on HTTP, and now if I want to send my GPS coordinates, I have to do it on HTTPS. But no one really knew the deprecation was coming. And this isn't to criticize the browser vendors, right? Like, they have a really hard job. How are you supposed to tell every website in the world, hey, by the way, if you use this thing, we're going to turn it off next month? That's a really difficult proposition, because even if they blog and tweet about it, obviously none of the developers from this organization read that particular blog or followed that particular Twitter account. And then that's like the end of the sources of information. But deprecation reports now fix this, because again, sending them through the reporting API, if you sign up for deprecation reports and you use a feature on your page that will soon be deprecated by the browser, it will send you a report and tell you. So had Sainsbury's been subscribed to deprecation reports for their site, they may have got something like this come through. Very similar concept, very similar JSON payload. They all follow a very well-defined structure. But we have a different type this time. This is a deprecation report. Happened on this website here. Then we get the ID, so it was a geolocation violation. The browser will tell you when we anticipate to remove this feature, so you can know roughly how long you have to get your things fixed before they break. And it says here, geolocation is deprecated over HTTP and will be removed in Chrome 50. And this is the file that tried to access it. How many people here actually keep track of all of the features that they use on their site and whether any of the browser vendors plan to deprecate them? And that's not kind of like to pick on you, because I know the answer is probably no one, because that's a really hard thing to do. I don't do it. Like, I will completely hold my hand up and say, I don't know. I don't know exactly every single feature that I use and the planned deprecation date for that feature. There may not be a deprecation date. But the point is, that's just really hard. So it's like, okay, you know what? I'll just subscribe to these reports. I'll just keep doing my stuff. And then one day a report will pop up and say, hey, in 6 months, we're going to kill this thing that you use. And I'll go, awesome. Open a ticket, replace this by then. Thanks. Problem solved. And it saves things breaking for you on your website. So deprecation reports are really good. That geolocation API was a particularly big one because loads of websites had their store locators completely break on them. So, what's after deprecation reports? Something called an intervention report. Now, intervention reports are slightly different because intervention reports are when the browser has intervened because of one of three causes. So either the browser thinks that your website is doing something annoying, the browser thinks that your website is doing something unsafe, or the browser thinks that the performance of your website is not acceptable. So in those three scenarios, the browser can actually step in and say, you've asked me to do this thing, but I'm not going to do it for this particular reason. And I have to say, I absolutely love the idea and can't wait for widespread intervention reports. When you think about this one, a request to play audio was blocked because it was not triggered by user activation. Who's been on a website and been like, where the frick is this tab that is playing this sound that I can't find? Right? It's like you open a tab and it pops somewhere and it's like, and I'm like, no, stop the music. So yeah, so we now have like, but if I'll show you my tabs later and they're like 3 pixels wide. So I can't even see the audio icon indicator. But this is a really good kind of point of like, if your website is trying to do something that's really annoying, like autoplay audio with no cue, autoplay video, if you're trying to send information over an insecure channel, if the user is on a slow connection and you're pulling down like honking big font files, the browser will say, I'm going to use a fallback font and kill that request because it's degrading the user experience. And it will send you the report. So if you have a particularly large mobile user base in like a particular country, you might get floods of these reports from those users and say, oh, hey, look at this. Like all of our users in France are having a really poor experience because they have bad internet there. And then maybe you could do something about that, but you wouldn't know about that previously. You wouldn't know about the browser intervening and taking this action. If the browser is doing stuff on your website, do you want to know about it? And hopefully the answer to that question is yes. If the browser feels like it is compelled to take action, you should probably know that it took that action. Intervention reports are how you get that information. So after intervention reports, we then have something called crash reports. And this is basically when the worst possible thing happens. Is like your website or your app managed to crash the browser. And there's only really one of these that you see. And it's this one. So this is a JSON payload for a crash report. Again, yep, you can see it says crash report just here. And just pretend that says crash report. You get the crash ID here, which you can take back to the browser vendor. And the only real one that we see here, the reason OOM is out of memory, And it's really ironic that Chrome is the only browser that supports this, because Chrome is probably the biggest browser that will cause these. You've used up all the memory on the device and something has crashed. Maybe again you have a client base on mobile devices that are supposed to be able to come to your website, but apparently it's just too hard for them. And I know that might sound silly when we're all here with all like iPhones and Android phones that cost $1,000, but some organizations have market shares in places where people don't have these really expensive devices. And if browsing your website is causing that problem, it would be really good to know about that. So that's just the things that you can send through the reporting API. Network error logging, deprecation reports, intervention reports, and crash reports. You can get all of those with those 2 response headers. And they're basically 1 line each. 1 line of code, 1 line of config, however you want to do it. But these are just the more recent features that we've had enabled. If you were in Troy's talk this morning, you will know already that there are other things that the browser can send as well. There's actually a whole host of information that the browser will send back to you. And all you have to do is ask it. So Troy demonstrated content security policy. This is really good. You say to the browser, hey, when you come to my website, I load all my images from this CDM. And then the browser notices an image loaded from a different location. So it says, I'm going to block that image. And then I'll tell you, hey, do you know you have this image on your page that you said shouldn't be there? Now, images are fairly benign, but imagine, like Troy's example this morning, it was script. Hey, all of our script comes from this one CDN. And the browser will say, okay, I've blocked this one from evil.com. Do you know you have script on your website from evil.com? And you're like, oh, whoa, no, I didn't know that I have. Thank you very much for blocking it. Now I will go fix the problem. Content security policy is hugely powerful. Interestingly, I have HPKP in here, and I do actually read the Chrome deprecation blog, because the last post that they published said they're going to deprecate this feature. So HPKP, for the people in my workshop, will have heard this, but it's a very powerful cryptographic mechanism to lock yourself to a certain set of keys. It's so powerful, in fact, and so many people, well, kind of like screw this up and break their websites, that Chrome has actually said, we're going to pull this feature back and we're actually going to deprecate it and remove it. So this is currently pending for deprecation in Chrome 72, which I think comes out in like February time from memory. Certificate transparency. How many people have heard of CT? Okay, not so many. This is a really interesting feature for me, and I think if you've never heard of CT, you should go and Google it and have a look. Go to a website like Search. Do I have time? Yeah, I'll just show you. It's okay. We've got time. So there's really good websites out there like Search for certificate transparency. And I really think that people could have a lot of fun with these. People doing OSINT like Niall up at the back there. You can get a lot of information from this. So you just go to a website like Search, which is a certificate transparency monitor, and then you say, hey, like I am DMB .no. Let's have a look. And it will simply list out, here are all of the different HTTPS certificates you have, because we now have transparency into certificates. So you can just go here and say, hey, what certificates do I have? Has someone in my organization got a certificate that they shouldn't have? Now, your website must comply with this policy. Your certificates must be public. And if they're not, the browser will reject them because they're not public knowledge, they're not transparent. So and your certificate authority is supposed to do this for you, and we rely on our certificate authorities to do it, but if they don't, which only happens very infrequently, I'll give them credit, then your website will not work. The browser will go to your website and say, this does not meet the certificate transparency criteria. I refuse to load the page. CT reports will tell you that happened. Feature policy, another fantastic one. Who here loads third-party JavaScript? Ads, like Niall's like me. Ads, anything that you load from a third-party source. So JavaScript can do really powerful things. We talked about the location API a few slides ago, right? So you go in, you load this third-party JavaScript. It's supposed to load a nice advert, and it's supposed to be good. What if it asks for the user's location? The user goes to your website, you got your little advert on the side, and then a location prompt pops at the top. This website wants to know your current GPS location. Now that's going to look like it's coming from your site because the user's on your site. But it's not. It could be a third-party dependency. What if they access the camera and it pops up, this website would like to access your camera, block or allow. Microphone. This website wants to access your microphone. These are really powerful features, and your site or things on your site can request access to them. If you want to make sure that doesn't happen, you can use feature policy. So you say to the browser, when you come to my website, nothing is allowed to use the camera API. Nothing is allowed to use the microphone. Nothing is allowed to use the geolocation API. So you can make sure that you and your site, but then also anything that loads on your site, cannot access these powerful features. And it gives you that added level of security. Last thing to look at, well, second last thing, Troy talks about the XSS auditor again. This is a really powerful built-in mechanism in Chromium, so several other browsers built on that. If it detects a cross-site scripting attack, specifically a reflected cross-site scripting attack, the browser will step in and say, it looks like this user is under attack, so I'm going to step in and I'm going to block it. If the browser is doing that, you really should know. You should have these reports enabled. If the browser is literally taking action to save your user from an attack, and you don't know, you're missing a critical piece of information there. And then the last one as well, OCSP expect staple. This allows you to determine whether or not you have OCSP stapling properly configured on your site, which is a very nice performance feature and a very nice privacy feature. You should have, and you should want to have this enabled on your site, but if you are supposed to and you haven't, the browser will call back and say, hey, by the way, this performance and privacy feature that you're supposed to have is not currently working, or it's misconfigured. So again, all of these scenarios, the browser will come back and help you. The browser will come back and save you from something that has gone wrong or will go wrong in the coming time. So I'm just going to jump out and show you a quick couple of demos, because this is really easy to get going with. So people may be familiar with my project, so full transparency, this is mine, security headers. You can come here and it just does a really quick scan of your HTTP response headers. So you come to the site, you whack a domain in, takes a couple of seconds, and it spits out the results here. You get a grade from A+ to F. And a lot of people misunderstand this as like a security testing tool or a security analysis tool. It's not really. It's an education tool. If you come here and get an F, Troy's not going to hack you tomorrow, okay? It doesn't work like that. This is just to help you find the features that you're missing. So as you can see, I've got all of the appropriate headers configured on my site. So if you come down, you can see here, these are my raw headers. So I'll zoom in a little bit for you. So again, HTTP, date, etc. Here's my content security policy header. Inside content security policy, you declare all of the places that I can load script from here. I can load images from here. I can do XHR requests to these locations. Forms can go to self. And then the more important thing you can see, report URI, but more importantly, report to default. So this is saying when something happens that's in violation of this policy, use the report to header and look for the default group. So if we scroll down, we'll see that I have the report to header here, and I have a group named default. You'll see that I also have my NEL policy that we talked about, report to default. And this is all it is, right? Like there's no code to deploy. You don't have to load a library in. This is native browser functionality. So the overhead of this is, I say zero. It's about as close to zero as you're ever going to get. There is nothing easier than a couple lines of code or config to enable these features. So we've got the XSS protection header here, as Troy demoed this morning. Again, you're saying to the browser's auditor, if you trigger and save my user from an attack, please send the report here. Now, all of these things are super easy to do. And it's like, I know that that I run a service that collects these, but honestly, like, go build your own collection endpoint. Go and, I'll take questions at the end. Oh, go on, it's you, Niall. Was there another header in there? So there may be some non-standard headers in there, XSS pwnage. So my service reads headers and then renders them into the DOM, and other services do that, and they forget to sanitize the things that they render into the DOM. So this is like me self-testing my own website to make sure that I'm always properly handling headers. I took out the XSQL injection one because I broke someone's website. That's not a joke. So that's how easy it is to enable all of these headers. Now, for the next part of the talk, we're still talking about reporting features, and it's still a reporting feature that we support, but it's completely different to everything that we've talked about so far. Everything so far has been about like web-based HTTP, set with response headers, usually about a web page or a website. But I want to flick and switch over to something called DMARC. Now, DMARC helps us with email. This is an email security and reporting mechanism. If you want its full name, it's domain-based message authentication and reporting conformance. DMARC from now on. So DMARC allows you to prevent people sending fraudulent emails that pretend or claim to be from you when they are not from you. And this gives us a hard technical defense against this problem. Now, for DMARC to work, there's a couple of prerequisites. As with everything with email, whenever I work with email, it's always really hard. DMARC is exactly the same. Email seems to be difficult. So this is the problem that we're going to solve. You open your inbox right now, and you have this email in your inbox. And it's like, to your email address, from no reply at reporturi.com, subject password reset. Hey, here's your password reset link. And this is probably text with a hyperlink that goes off to some spam phishing site or something. How do you know that email's actually from me, from our company? Right, like it says it's from reporturi.com. An email server is connected to us and delivered this email and said, hey, this is the from header. We are reporturi.com sending you this email. Right, and our emails come from all different locations. We use things like SendGrid. We have our own email server. So, it's like, how do you determine that this is actually genuinely an email from report-uri.com as it claims to be? And this is what DMARC helps you to A, check, and then B, detect. So the first thing that you need to do is deploy something called SPF, which is Sender Policy Framework. Now, SPF is just a single DNS text record. That's all you need to do this. So you set a text record on your domain, and you put v equals SPF1 at the beginning. That's how you indicate this text record is an SPF record. After that, you then list the locations that you're going to send emails from. So you have this include directive. Now, messagingengine.com, I use a company called Fastmail to process and do all of my emails for me. Now, this is their kind of separate domain that they have. This is where they send the emails from. So if you do a DNS text lookup for this record, it will pull back all of their IP addresses, all of the locations that they say, we will send emails from these IP addresses. So now if you receive an email that claims to be from me, your email service provider can look up this record and say, okay, Scott has told us that he will send emails from here. And they'll go do a lookup on that, and they'll check the IP addresses. And then they'll look at the source IP of the email. Where did the email actually come from, and is it on this list? Because if this email was sent from an IP address not on this list, then this isn't a location that Scott has said he will send emails from. So already we know something about this email. This is possibly not what it claims to be. Then we have a second mechanism that we can deploy alongside that, called DKIM, which is Domain Keys Identified Mail, just DKIM. DKIM is slightly more technical because it allows us to add a cryptographically verifiable signature to our email headers to prove that it definitely came from us and hasn't been tampered with. And what we do is, again, we create a DNS text record. So you can see here, text record for my domain. If you have a hosted email solution like I do with Fastmail, if you use Gmail, Office 365, or is it Office 364 today? Is it still down? So, I'm sorry, that was terrible. You put the key into DNS, and then when someone receives an email, again, that claims to be from your domain, so you get an email that claims to be from me, you can go into DNS and you can fetch this key, and you can verify the signature on the email matches. Now, if the signature matches, you can say, okay, yeah, this pretty much definitely came from Scott, because we can verify the signature. Again, if this doesn't, and you can't verify it, you can say there's probably something wrong with this email. Now, I say probablys and maybes there because ultimately you get to decide what happens. And this is where DMARC comes in. DMARC is the final piece of the puzzle. SPF allows you to list the IP addresses of your mail servers. DKIM gives you the cryptographic key for the signature. And then with DMARC, you get to say what happens. How do we want people to use this information? So we create the last thing, which is our DMARC record. It's another DNS text record, and you put it at _DMARC on your domain. V equals DMARC1 to indicate this is a DMARC text record. And then here with the policy, you get to say, if you receive an email from me and something looks suspicious, you get to say what happens, and you have three choices. You can either say, I don't care, accept it. you can do what I do, which is quarantine. And quarantine means do something to indicate to the user this might be suspicious. So generally speaking, that will go to the spam folder. They may put one of these banners at the top that says something about this email is suspicious. But it says to the mail provider receiving it, do something to tell the user there's maybe a problem. Or if you're really brave, you can just put reject, in which case they'll just toss it in the trash. This is good. This protects the user. If someone tries to impersonate or spoof me, then the emails will go to their spam folder, which will give them these alerts straight away that something is probably wrong with it. But if someone is sending emails and trying to spoof me, I want to know. Is there like an active spam campaign where people are trying to attack our users? It's the kind of thing that I want to know about. So please send me the aggregate reports here. And what mail providers like Google, Microsoft, all of the big players around the world support this, is they will look at all of your emails coming in and they will do these SPF and DKIM checks for you. And if something fails one of these checks and they take action, they'll make a note of it and say, okay, yeah, we got these emails in today. They looked a bit suspicious. We put them in spam. And then at the end of the day, they will send you the email with the records of what they did. And you will also, so they will say to you, hey, yeah, we got 1,000 emails. 990 of them went to inbox. They're all good. But we got 10 spammy ones. Here's the IP address and all the information about these dodgy looking emails. Here's what went wrong. You said in SPF these are your IPs, but this is the IP we got it from. Now you might look at that and it could be like crazy Russian IP, maybe something's gone wrong. Or you could look at that and go, that's SendGrid, we use those. I forgot to add them to my policy. So you can detect misconfigurations and a genuine attack. So these are really powerful. They will gather these up for the whole day. Once a day, overnight, they will send you the report and you'll wake up in the morning and you'll know exactly what happened with your emails the day before. Last couple of parts on here. You get to choose whether this applies to subdomains as well. So if you were applying this to just scotthelme.co.uk, you may also send emails from subdomains on your domain. In that case, you want relaxed here, but you can set the policy to strict and say, I don't send any emails from subdomains, in which case they're all bad. So again, it's flexible enough to do everything that everybody needs it to do. So to test my DMARC policy, I sent some spam emails. I'm going to demonstrate a service online where you can do this. But you can just forge up an email that says, yeah, I'm from scotthelme.co.uk, and hit send, and it will get to the other side. So I did this to impersonate our service, and to test out DMARC and to see what kind of reliability we get from providers out there, I sent one to my Gmail address. So I sent an email and forged the from address here to make it look like it came from report-uri.com when it didn't, because I spun up a server online to send the email. The IP of that server is not in my SPF policy. So Google put this at the top. Be careful with this message. Gmail could not verify that it actually came from report-uri.com. If I'm sending faked emails to your users, you really want that banner at the top. You really want it to say that. So this is the quarantine thing in action, right? Like Google aren't deleting it or throwing it away, but they're giving a very clear visual indicator that there is something potentially wrong with this email and you should be careful. Microsoft just shoved it straight in my junk folder. This message was identified as spam. Similar kind of thing, right? If the user goes in there and sees it in their spam folder, they're probably already at the start of a process of like, this might be spammy. I think I prefer the Gmail one. This to me is the kind of thing that I want. I would like much more overt warnings. If I define a policy and this email is in violation of that policy, then I really want a big visual indicator to the user because they will pay attention to that. I think a lot of us expect stuff to go to spam sometimes, so I'm not quite sure if that's the action that I'd like. So just to show this in action, and if we jump back here, because I'm going to go show you the actual report. So this was the 21st of December 2018 when I did this test. Of course, we support DMARC reports, so I'm going to go and look at my actual DMARC reports right now. So where are we? Here. So I went back to the 21st of December 2018, I'll zoom in so you can see, and I pulled back all of my reports from then. And if we scroll down, there's this one here. And I'll just close that. I'll just close that up for a second. Whoops. So we can see there was a quarantine action here. Got a big red cross on it. The domain that was being impersonated, the domain that the email related to, was reporturi.com. This report came from google.com, and then reports have a unique report number. but this is the actual payload. And DMARC reports are XML. They're not JSON. So they're sent as an XML payload as an email. And then here is all the information that I need. Somebody sent an email about reporturi.com, claiming to be from reporturi.com. If I scroll further down, you can see the source IP address of the server that sent it. Just here. Let me zoom in for you. So you can see the source IP. What action did they take? Well, we quarantined it. We did something with it. Quarantine doesn't literally mean like we quarantine the email. It just means take some kind of action. So it's not quite a strict representation of the term. The identifiers, the from header, said reporturi.com. And Google sent me this. This report comes directly from Google because I sent it to my Gmail address, impersonating a domain that wasn't mine. And this is a really powerful mechanism. Most of the time, what you want to see on here is these green ones, right? So like you want to see green. This is an email provider saying to you, yes, we got lots of emails from your domain today. They all look good. No one's trying to impersonate you. No one's trying to spoof your domain. No one's trying to spam your users claiming to be you. So this is the kind of thing that you really want. Because sending these emails is really easy, right? I literally just went into Google and said like spoof email from or something like that. And it was like, you can just go down to like page 1, there you go, fake emailer, right? So this is how easy it is to just send an email from name. So we're going to send an email from just some random person. Try, no, I'm kidding, we won't do that, it's mean. So let's just send it from scott@reporturi.com. So we'll send it to Gmail because I like their blocking much better. Subject, lols, and then test. So that will send that right now, assuming I pass the captcha. Dun, 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 dun. Takes a second. There we go. So that's been sent. So basically all this service does is lets you just forge an email claiming to be from someone and send it. Now, because I have SPF and DKIM and eventually DMARC configured, when this lands, excuse me, when this lands in my inbox, I should be able to see that it has that big warning on there again. Go Wi-Fi. So if I go down to more, oh, why isn't it loading? Come on, there we go, spam. So it should go into my spam folder. So I'll give it a second to come through. The one thing that I won't be able to show you, and the reason I showed you the DMARC from the last one is, like I said, the mail providers will collect all these reports up for a day and then dispatch it at the end of the day. So I won't get the DMARC report for the fake email I just sent until about midnight tonight. So they are delayed and staggered by 1 day, which is why we had a look at that old one. But if I have a look in here, hopefully if that service is working, we should see that come through. Let me just check my phone, see if it lands up. But essentially, that's DMARC reporting in action. That email will either go to spam or will go to my inbox and have a big honking warning over it. And that's the kind of protection, really, that you want on your emails. Super easy to set up, 2 DNS records. If you're using a hosted email provider like Gmail, G Suite, Office 365, they will literally give you copy and paste records to set. You don't actually have to do anything at all. And that's why I kind of like the idea of just enabling these features, right? Like they're super easy to do. The headers we looked at before, couple of basic values. If you're using an email provider, again, couple of basic DNS text records. And you get all of the protections that we've just talked about, and if you wish, all of the reporting to let you know when things go wrong as well. So that's everything from me. I hope that was entertaining and interesting, and thank you very much. So, questions? Yes?
So the email thing, wouldn't it be kind of solved if we just use always use SMTP over SSL and just rely on the certificates there to verify the identity and only allow emails to be sent from the person holding the certificate with the identity most company?
Okay, so I'll reiterate the question for the crowd. Essentially, could we not use SMTP, SSL, and certificates to validate the host names on the servers instead of depending on things like SPF and DKIM? And the answer is no. The answer is a really short no, because we don't always send emails to and from servers that bear the host name of the email that sent or received them. So I don't have a scotthelme.co.uk certificate on my mail server because I use Fastmail. So essentially with something like SPF, what I'm doing is I'm delegating my email sending capabilities to them using the SPF record. So you can't then say, oh, well, the mail server must have a scotthelm.co.uk certificate because the email says scotthelm.co.uk. Any more questions? Yes.
Can someone use my report URL and just spam you from his site? Can I?
So can someone send reports to your report URI address and spam you? The answer to that is no. Very early on we saw, when we were a young service, we saw lots of kind of attacks like this, people sending spam and junk through. But what you can do inside your account to prevent people from essentially using up all of your account quota, if you come into the filter section here, we have a list of hosts that you expect to collect reports for. So if you just specify like your domains in there and then someone tries to flood in a load that aren't for you, we'll just toss them away and it doesn't cost you anything.
Are there any problems given that the user doesn't know he or she is sending out these reports?
Okay, so I guess the question there is around privacy, and it was, is there a problem the fact that I guess the browser is sending these transparently without user knowledge? I'm really comfortable with how reporting works because when the user comes to your website, they have no idea what sub-resources are being loaded from third-party domains. They have no idea about AJAX requests being fired off. So when someone goes to a website, you're already making an acknowledgement that I'm going to go to this website and they'll know some things about me. We're essentially just collecting additional diagnostic information. By collecting this information, we don't know any more about the user than we know because they came to our website. So they made a HTTP request to our website, and then maybe they make another HTTP request for the report. But it's still the same principle, right? Like it's still the same amount of information. So we don't actually learn any more than we knew in the first place.
For example, if one visitor comes for the very first time to your site.
Yep.
And then
So yeah, so we have what we call the tofu problem. The question there was, what if it fails on the very first time? You're screwed. Like the user must make one successful connection the first time, and then the policy is cached for however long you specify going forwards. So ideally, you would deploy this whilst everything was working, and then when everything goes wrong in the future, that's when you learn about it.
Is it possible to kind of unsubscribe on an error that you're acknowledged? For example, the deprecation, I wouldn't want anybody to tell me if I already know that I have it.
Okay, yep, so that's another really good question. And that was, let's say like the geolocation deprecation, I'll use this as an example. Once you get a load of reports through to say, hey, you're using this deprecated feature, how do I stop them coming through? The answer is, you can't stop them being sent, because if you have deprecation reporting enabled, the browser will continue to tell you. What we can do is filter those out on our side. So you enable or disable deprecation reports. You can't say to the browser like, hey, I know about this thing that you told me, don't send them. You just have to throw them away when they come in once you acknowledge the deprecation. Any more questions? Yes.
With this offline, when your site can be reached and the browser can send the report later, does it happen that you get a bunch of just reports which are basically caused by some crappy internet connection? It's like, and don't you get spammed with that?
No, so if you're on a connection and you don't have any internet connectivity, do you mean?
Something in between, right?
So yeah, so this is the interesting thing, right? There are a couple of scenarios where, and the question was like, what if something is screwing with your connection or you have no connection? Like, so if you're behind a firewall or a proxy and it's terminating the connection in some non-graceful way, then you could, and most likely will get reports about that. Pretty much all scenarios, because, you know, like if the proxy is switching out an invalid certificate because it's wrongly configured, then you will get reports for that. But at the same time, I can kind of see why you wouldn't want to. At the same time, that user is experiencing problems on your site that they may think are because of you. So if you know about that, it's a scenario where you could potentially explain that better. Nelly's very young, network error logging, and the reporting API is very young. It's only been in Chrome since like September. So just like the feature in the browser and us as a service, we're still learning a little bit because we're only in the first steps, and these things will get better over time. Yes?
how do you know that requests are coming from my side? Kind of idea of spam?
So yeah, so the question was, how do you know the requests are coming from my site? The answer is that we don't. So if you imagine we're just receiving like a blind HTTP post with a JSON payload that could look something like that. So a browser has sent us this payload as a HTTP post. That's all the information that we get as a service provider. That's all the information you would get if you set up your own reporting endpoint. So yes, these are potentially very open to being spammed. As a service provider, on a good day now, we're processing about 500 million of these a day, a billion with a B. We actually don't see that much spam as such. Like, we don't really see people just crafting reports and sending them for the lols. We do see people sending like awfully large quantities. If you have a very heavy traffic website, you may get flooded with these things, but we've not really come across any incident that's come across our radar where someone has just fully crafted a report and sent it. So the answer is yes, they could do that. You wouldn't be able to tell. But I also question, like, okay, so they send that, what would they get? I'm out of time. So yes, they could do that. I don't know what they would gain, but it is entirely possible. I am out of time now. If there are more questions, please come and find me afterwards. Happy to talk about this stuff, and thank you very much again.